I want to ask you to go back in time and try to imagine yourself sitting in high school, in a chemistry lesson, or maybe in a science lesson. Try to remember, what did you learn there? What contents, what concepts did you learn in this lesson, in this course? Okay. So maybe it will not surprise you, but today, students still learn the same concepts that you were learning years ago. Maybe not so many years. But as we heard today, science is going forward, and we have such exciting ideas and exciting concepts, and contemporary science is so fascinating, and there is a huge gap between what students are learning in school and what we are doing here at the Weizmann Institute or in other research places around the world. And still, students keep learning these basic concepts. And maybe you might think, okay, this is reasonable because we need to start with the basic and to build upon it more complex concepts or ideas. Here you can see Avogadro. But I want to tell you that in my research group in the Department of Science Teaching, we study what happens to students who are exposed to exciting new contemporary research. Their motivation to learn science increased. They want to choose careers that involve science. They don't think that science is conducted only by white men, because this is what they see in school. Actually, scientists today, they don't look like Avogadro. They look like you, they look like us. And we found that when students are exposed to a contemporary research and contemporary scientists, they can be identified with these people, and they can imagine themselves being scientists in the future. So I think you might wonder now, how do I know that exposing students to contemporary research is elevating motivation and influence the students? So a few words about how we conduct research in the Department of Science Teaching. In my group, for example, we use in our group, in our department, we use science research tools from social science. We use our lab is a class. Our lab could be a teacher or a group of teachers, a group of students, and we listen to their opinion. We use statistics to quantify their opinions and ideas and understanding. And in this way, we build our understanding regarding teaching, regarding learning, regarding motivation, regarding learning programs and curriculum. So I think I refer to the question why it is worthwhile to expose students to contemporary research. But after we understand it is really worthwhile, we might ask ourselves, what should we teach in the contemporary research? Because contemporary research is keep growing and keep changing. And I will take the example of nanotechnology and show you how we answer the question of what should we teach. Okay. So in order to choose what are the concepts that should be taught, for example, in nanotechnology, we conducted a research that is called a Delphi methodology research. We consulted a community of experts in nanotechnology research and experts in teaching that knows about nanotechnology. And we asked each one of them, what are the basic concepts of nanotechnology that are worthwhile to teach in high school level? We used then statistical tools to collect their opinions and also to reach consensus. And actually, we reach consensus regarding 8 essential concepts of nanotechnology that should be taught in high school level. Okay, so I will not go into the 8 concepts, but after we found what are the essential concepts of nanotechnology that are suitable for high school level, we ask ourselves the how question. Okay, if these are the concepts, how we can teach them in school? And in order to answer this question, I want to expose you to another approach in our department. We don't just conduct research about science education. We take the results and the insights from this research and try to influence the educational field here in Israel. So in order to implement these 8 essential concepts, I developed a course for high school teachers, for chemistry high school teachers. And in this course, they learn these 8 essential concepts. I gave the course in Hishtalmuyot, workshops for teachers, and also in a master degree here in the Feinberg School. And we also conducted an online open course for teachers and exposed hundreds of teachers to the basic concept of nanotechnology. Then we asked the teachers, okay, these are the concepts, but how they are connected to what you are actually teaching in school? And the teachers suggested a lot of insertion points of these 8 essential concepts to the existing curriculum. And for each part of the curriculum, they suggested you can, here you can connect this concept, and here you can connect this concept. And by collecting their ideas and analyzing them, we created a rich network of connections between contemporary research, for example, nanotechnology, and the existing science curriculum. So I want to talk only about one of the essential concepts. I chose the most special one. That is, actually, it's not a scientific concept. It's about the nature of the developing of the contemporary research. And I call it authentic science. And authentic, it's not from authenticity like you can imagine the yoga at the end of the day. Authenticity, it's a nature of the science. It's what you are doing in your labs. It's about conducting research. It's about working with advanced equipment. It's about analyzing the data and discussing the idea with colleagues, all the things that we are doing in order to develop the science in the lab. And if you think about this concept, authentic science, it's really tricky how to teach it, because I don't want to give a lecture about how scientists are working. So you can, for example, invite high school students and teachers to join your lab, and by doing that, they are exposed to contemporary research because they work with a scientist, and they see their everyday work and how they discuss ideas and how they develop their understanding. But here, there is only a limited number of students that can have this experience. So we decided, okay, let's invite students and teachers to research conferences. And we invited the hundreds of students to the Nano Israel conference every year. And by this, we expose them to authentic nanotechnology. But here, again, a limited number of students can join this experience. So we decided to develop an outreach activity with the electron scanning microscope that Weizmann purchased for educational use. And we designed this activity in a way that it will expose the students and the teachers to the authenticity of the science. For example, they prepare the sample to the microscope. They work and operate the microscope by themselves. They discuss with the scientist, a PhD student like you, like Karen Kahil that is sitting here and took part in this project, and they feel the way science is developed and is conducted. But again, we wanted to reach even a wider audience. For example, students who live in the geographical periphery of Israel, So Ella Yonai, that is an excellent PhD student in my group, she developed a remote activity with the electron microscopy. And the students are actually operating the electron microscopy from their own home or school. They prepare the sample, they send it, and they feel they are doing a real research. And the challenge was how to develop this activity and actually keep the authenticity of the activity. And by measuring with the research tools that we use, we found that the remote activity in some aspects are even more authentic than the face-to-face outreach activity. So we discussed why it is so important to expose high school students to contemporary research. And I also showed you how we found what concept should be taught. And also we discussed how we conducted this experiment. And to sum up, I want to thank my research group here, the chemistry group in the Department of Science Teaching. And I want to ask you a question to think about it later on. What was the activity or the person or the mentor who lighted your spark to pursue a science career? And to thank you for your listening.
Thank you very much for this very important talk. Wow, I got inspired. Questions? Yes, Celine?
Yes, you've talked a lot about exposing young students to the current contemporary researchers, but how to motivate them?
Okay, so by exposing them to contemporary research, actually we found this is a way to motivate them. We usually work with the teachers, and when the teacher is able to integrate in her teaching some new idea, some how the universe is created, supernovae, all the exciting things that we heard today, for example. So when the teacher is able to integrate these ideas, these contemporary ideas, it sends a message because your studies are still open. There are a lot of open questions. And the old textbook studies, it's all closed. All the questions have the answers. So when I'm, as a teacher, I'm able to show the students that things are still open. We need you to further study these things. This is a way to motivate them to choose a science career. And additionally, when you see all the faces that conduct the research, we are so varied. It's not only this white men who conduct research and they are very smart. I'm not able to be identified with such persons, but all the different faces, every student can find someone who looks a little bit or be identified with him and think about herself or himself as a future scientist.
You mentioned that you took the students to conferences about nanotechnology. Mm-hmm. Did they have the tools to understand the research there? Because I assume that the researchers were speaking in their own jargon and technical terms, and it would be hard for the students to actually understand.
So it's a good question. This is why we said it's a limited possibility to invite students, because we could choose only very advanced students and that their English is very fluent. So they will be able to follow at least part of the lectures. And it was amazing because you see 100 students in a very international conference. And I remember in one of the plenary talks, one kid, he was 9th grade, he left his hand and he asked a question and everybody were amazed because it was a phenomenon. But again, you are right, because this opportunity is open only for students who are advanced, who have background. Yes.
Just a second question. Do you have any, are you trying to motivate scientists from Weizmann to speak to those young students, to speak in their own language they can understand? Is this something that you do?
Okay, so one of our studies, we interviewed the researchers from the physics department, And in this interview, we developed a tool that helps them to communicate their idea for school students. For example, jargon, as you said. And from these interviews, we realized that one of the most important concepts that they make it easier for them to communicate their research is identification methods. For example, the electron microscopy. And this was the reason why we chose to use the electron microscopy as an outreach activity. So I didn't tell the whole story today, but yes.
It's more tactical.
Maybe a good activity that will tackle both things is to do kind of a TED conference that will also stimulate scientists to tell the research easy, and it will perhaps motivate students, and I think everyone will get benefit from it.
Mm-hmm. Yes, I think that in such an event, when you see different faces, different people speak with a lot of anxiety about their own research, it's a very good way to motivate students. Yes, thank you.
We have time for one last question.
This is wonderful, but at the end of the day, the students and the teachers and the principals are bound by the program of the Minister of Education. And once they reach 11th grade and 12th grade, all they have in mind is the final exam, the boot. And the teachers are actually evaluated by the scores of the. So I think that you're talking about kind of a bottom up, and this is, I guess, from what I hear, it's limited to excellent students or kind of more restricted. But what do we do in order to encourage? And this is something that is ongoing for 30 years.
Mm-hmm.
The Minister of Education, to accept this form of teaching.
Mm-hmm. So actually, what you're saying that changes are really, I agree with you that changes in the system are very slow, because it will take 30 years to change the curriculum and to introduce contemporary research into the curriculum, and then it will not be contemporary anymore, okay? So we work in both directions. On the one hand, I'm a member in the committee of the not matriculation, but of the program, and we try to influence from top down. But on the other hand, when I work with the teachers, this is a bottom up, but it's a real bottom up, and all these teachers, they meet the students year after year, hour after hour, and they have the ability to influence. And sometimes even a small experience will light the spark in the eyes of the students. So I have a lot of hope. This is why I chose what I'm doing. And I think we can make a change. Okay.
Yeah, I think it's very important, because sometimes people ask me what you're going to do with degree of chemistry, or the surprise that in battery there are chemistry. So maybe it will expose, it's not only equations. And let's thank again Professor Ron Blonder. Thank you.